Do you want to do the cpm.org again?
Yeah. Just go to cpm.org.
Yep.
Let me save that. And it was over on the left.
Homework help. And then it's Course Connections, Chapter 4, or Course Connections, Course 3.
Where's that? Oh, was that on the left?
Go down to the books.
Ah, I got it.
And it's Course 3.
Okay, and then Chapter 3 also?
Chapter 4. I think. I'm pretty sure it's Chapter 4.
Okay. Yeah, this looks right. Which one?
What did we do last week? Alright, here. Let's just do 4-2, number 2.
Well, we did a lot of these last week. We don't want to.
Okay.
We don't want to work on the same stuff we've worked on.
Yeah. So.
Have you covered all of these, or are some of these beyond what you've gone over yet?
Most of these are beyond what I've gone over.
All right. I don't think we did 4-2. Let's have a look at it. It seems like we started at 4-4 or something. Yeah. I don't remember seeing any of these.
No.
Have you been covering this kind of stuff
Yeah.
in your school?
Yep.
Well, this isn't. I don't know. I'm not understanding this, I guess. What are they asking for here?
You have to find the figure 0 and the fourth figure by figuring out how much it's going up by, like how much it's adding. Like if you click on the little answer tab, it'll tell you the answers.
Oh, I see. Okay. I forget that. So figure 0. Okay, so this is figure 1. Figure 0 is subtracting 1 from the width and the length.
Yeah.
Okay. And figure 4 would be taking figure 3 and adding 1 to the width and the length. All right.
Mm-hmm.
And so they want us to do B.
Mm-hmm. So figure 0.
It's going to be a little tough for us to do online.
Yeah.
These problems. They're so graphical in nature that I could graph them and we could say, but it would take me a long time to graph this.
Yeah.
If we can see what's going on here, what's the difference between figure 2 and figure 1?
You're taking 1 off of the top and like 1 off of the
Horizontal, right.
Yeah.
Okay, so figure 0, you're going to take 1 off the top, reducing it to 3 rows instead of 4 rows.
Yep.
And you're going to take 1 off this one right here and this one right here, reducing it to 3 columns instead of 4 columns.
Yeah.
And figure 4, you're just going to add. We don't add to the ends. We add to the left side. Notice. In other words, we don't just add 1 on the end. Notice the difference between figure 1 and figure 2. Both have 2 there. So when they increased it, they just added a column right here. So the next figure, you want to add a full column, not another stone on the end. And then the same for figure 5. Okay? Well, let's go to a section where we don't have to do this graph stuff. Let me see if I recognize some of this. I'll recognize it if we've done it before. I recognize this one, all these K's. So we did 4, 4. We probably did 4, 5. Probably did 4, 6. I think we even looked.
Do you want to go to chapter 5 instead?
Sure. I mean, I want to go to whatever you're working on. And I don't mind if we cover stuff that you haven't covered yet. That's okay with me to give you a little bit of a head start. It kind of depends on how far behind you are in the stuff that you're working on in school right now. Or if you're all caught up, it's fine for us to get a little bit ahead.
Mm-hmm. Okay, so that would be, that equation would be y equals 7x plus 5.
Good.
Yeah. Okay. So, would you subtract 22?
Yeah. Let's talk about solving equations.
Okay.
Your goal, when you look at this equation, is to end up isolating x. That's the sole purpose you have in mind. In other words, I want to eventually get to where I can say x equals some number. Okay? So, work backwards. How am I going to isolate x? Well, first of all, I got to get rid of this plus 22, and then I got to get rid of the coefficient 2. So, I want to subtract 22 from both sides.
Yeah.
Which gives me what?
2x equals negative 12, right?
10.
Negative 10, yeah. Mm-hmm. And then divide by 2.
Okay.
Which is x equals negative 5.
Okay, good.
There you go.
Now, there's no place here to put the answers, is there? Not that we need to. Okay, how about 2x minus y equals 3? And this says solve for y. So now my entire goal is to isolate y.
I don't really know how to do that, I don't think.
Well, what do we want to do with the 2x? Move it to the other side.
Okay.
In other words, we want y all by itself. Well, if I subtract 2x from both sides, I don't quite have y all by itself. I have negative y equals 3 minus 2x. Now how do I solve for y?
Then you would do...
What do I have to divide by in order to get y all by itself?
2x.
No, I got to divide by minus 1.
Minus 1?
Uh-huh. That minus y divided by minus 1 is equal to y. The minuses become a positive and you end up with y.
Y equals...
And 3 minus 2x divided by minus 1 is 2x minus 3.
Okay.
In other words, there's a thing that says a minus b is equal to the negative of b minus a.
Okay.
So I could always make the following statement that 3 minus 2x is equal to the negative of the reverse, 2x minus 3. Now, that's only true if you're subtracting. It's not true if you're adding. In other words, 3 plus 2x, I can't reverse those and put a minus sign in front of it. So be careful about that rule. But this rule right here is a pretty important rule in math to remember.
Yeah.
Okay, now let's go back for a moment and see if there maybe isn't a better way to do this problem that you would like better. What if I move the y to the other side and the 3 to the left? In other words, I'm going to move the y to the right and the 3 to the left.
Okay.
Well, when I want to move something, I just move it and change its sign. So that becomes plus y. And if I move the 3 to the left, that becomes minus 3. So I immediately, first step, well, 2 steps I suppose, solve for y. Just because it's on the right side of the equation doesn't mean anything. It's just as good of a solution. In other words, this is the same thing as y equals 2x minus 3. But notice it was a little easier to get. I had to do 2 steps. I had to add y to both sides, and then I had to subtract 3 from both sides.
Yeah.
But it solved the problem of having to deal with that negative y. The first time we did this problem, we moved the 2x over, and it left behind a negative y. Negative numbers are always going to cause a little bit of a problem. They're just harder to deal with. So if you can solve an equation in a manner that leaves you with positive numbers, that's an advantage. You're less likely to make a mistake. Not just you, but everybody. I mean, this standard instructions that I give to my students is, if you have a choice on how to solve an equation, try to leave stuff as positive as you can.
Yeah. So in this one you're going to do, I don't know, you can just do plus 15 on both sides. You can plus 15 on both sides.
Okay.
30 equals 2x.
2x plus 30 equals 2x.
Yeah. And then
This is a trick question. Whenever you see the same variable on both sides and it's not being multiplied by anything, it's just being added or subtracted to stuff, like this 2x is, I can subtract 2x from both sides, right?
oh yeah,
What does that leave?
30.
Leaves 30 equals 0. Whenever you get this kind of an answer, that tells you there is no solution to this problem. There is no value of x that makes this true. It's kind of like saying, can x plus y, if that's equal to 5, and now I also say the same x plus y is equal to 10. That's impossible. They both cannot be true. Well, I also can't have an equation like x plus 5 equals x plus 3. That's impossible. If I subtract x from both sides, I get 5 equals 3. So whenever you get one number equals a different number, that means there's no solution to that problem. Okay, this one they want us to solve for y. So think isolate y. the first step?
You could, would you subtract 2y?
Well, that's going to put it on the other side and make it negative.
Okay.
So in keeping with the thought of let's try to keep a positive sign in front of y, it'll make the problem easier, what would be better to subtract? 6x or 2y?
6x.
Okay, so it makes it 2y equals 10 minus 6x.
Yeah.
Now what?
Then you do subtract 2y.
No. Remember, we're trying to isolate y. We almost have it isolated. We're real close. It's just got a 2 in front of it. So you might be inclined to say, well, what if we subtracted 1y from both sides? Let's see what happens if we do that. I'm going to subtract 1y from that side and 1y from this side. Well, what does that leave? That leaves y equals 10 minus 6x minus y. When they ask us to solve for y, this is not a solution.
Yeah.
Because we haven't solved for y in terms of numbers and x's. We've solved for y in terms of numbers, x's, and more y's. So whenever they tell you to solve an equation for y, you want to make sure that there are no y's on the other side in your answer. So
Yeah.
I don't want to subtract 1y. But what happens if I divide both sides by 2? Now I'm left with y all alone, which is what I'm looking for on the left side, 1y. And now on my other side of the equation, I split that into 2 fractions. That part is 5. This part is 3x. This part here.
If it's like this, can you just take the 3x and switch it with a 5? Like, so it makes it easier?
No? Well, what do you mean?
Like, because like...
In other words, that's not the same answer as 3x minus 5. Those are different answers.
Oh, okay.
5
Okay.
minus 3x is different than 3x minus 5. It's the negative of it. In other words, this would be minus y. But we wouldn't want to switch them. I think you wanted to switch it so you put the variable first and the constant second. So
Yeah.
I could, if I wanted to, write this as minus 3x plus 5. That's acceptable. But I don't know why you would do that. In other words, it actually looks prettier in this format. You don't really want to start out with something, well, I don't know. These might be equivalent answers. If your teacher has said, yeah, put the x's in the first position and the numbers in the second position, then you'd probably want to go with this. But notice that you have to switch. In other words, you have to carry forth this negative sign if you're going to switch these two terms. It's fine to do it, but make sure you keep the negative sign in front of the 3x.
Yeah.
I wouldn't do it. I would leave the answer like that. That's nice and straightforward and simple and clean.
Okay.
Okay. Let's see. We want to go to another one here. I want to go to 5-7. This is actually excellent
Yeah.
math review, I think. I mean, you know, those first couple sessions where I came over and I was making up problems. I would have much rather had something like this to work off of. It's because I can't always be as creative when I'm making up problems. Some of these give you some really interesting situations. So, what do I want to do here?
you have to find a common denominator?
No, we're not adding or subtracting. Remember, you only find common denominators if you're adding or subtracting.
Okay.
I want to isolate x. What can I do to the left side of the equation to isolate x?
Subtract 16?
No. In other words, x over 16 minus 16 does not equal x.
Okay. So
what do I have to do to this so that it will equal x?
do you subtract 16 from both sides?
No, that won't change it into x. But what if I multiplied both sides by 16? Now, notice what happens on the left. The 16s cancel each other, and I'm left with what I want, which is x. Okay? Now, to solve this on this side, I'm going to turn that into an 8, turn this into a 5. You see how I did? I turned 16 over 10 into 8 over 5. Now I can multiply. Now I got 56 over 5 is my answer.
Okay, I see.
Okay? So that really was just a single-step problem. Just multiplying by 16 isolates x. Whenever you have a denominator in an equation, that's generally what you want to do to get rid of it, is multiply by the denominator. In other words, if I have this problem here, what's my first step?
Would you multiply again?
By 7.
7, yeah.
Okay, I multiply the left side by 7, multiply the right side by 7, and I'm left with x plus 4 on the left. I'm left with 28 on the right. Now what's the next step?
And then you subtract 4 from both sides?
Correct.
Which
So
would be
x
equals 24.
Exactly. Remember, you're always going through these equations step by step trying to get x isolated.
Yeah.
In the numerator, not the denominator. So
Can you flip them?
Yeah, you actually can.
Would that be easier? Or would it just be like multiplying by 3 on both sides?
Well, there's always multiple ways to do these. It's really just what is your preference. My preference when I see a fraction equals another fraction, my first step is to cross multiply. You've heard that term?
Probably.
That times that equals that times
yeah.
that. So I got 6x equals 45. Now what?
Divide by 6, both sides.
45/6. 3 goes into both of these. 15 halves. There's your answer. Do you see how I converted 45 over 6 into 15 over 2?
Yeah.
I divided the top by 3 and the bottom by 3. Now, let's go back to this one over here. Why did I not cross multiply as the first step here?
Because
I can isolate x in one step by just multiplying both sides by 16. I don't need to cross multiply. If I cross multiply, I'm going to have 10x equals 112. And then I have to divide by 10. So 112 divided by 10. In other words, I have to go through 2 steps if I cross multiply. I didn't need to cross multiply because x was in the numerator, and is all I needed to do is one step, multiply by 16, and I've got x isolated. So the one thing you do want to do is always do the fewest number of steps that you need to. You don't ever want to do more steps than you have to. So it was unnecessary to cross multiply and actually counterproductive. However, the moment you put x in the denominator, like the next problem where I had 6 over 15 equals 3 over x, notice I can't solve for x in one step. There's no way. I can divide both sides by 3 so that I have 6 over 15 divided by 3 equals 1 over x, but that's not isolating x. In other words, 1 over x is not the same as x. So I chose as my first step to cross multiply so that I would get x out of the denominator. Now, you had an interesting suggestion that I actually like. You can flip them. So if 6 over 15 equals 3 over x, then 15 over 6 equals x over 3. And now I can solve this in one step. I don't have to cross multiply this. So all I have to do is multiply both sides by 3. And I end up with 45 over 6 equals x.
Yeah.
Okay, number C. 2x over 5 equals 12 over 8.
Oh, okay. Would you do the cross multiplication thing?
Yeah, I'm not sure that, that's one way to go. So 16x equals 60, that's one step, only one more step.
Divide by 16.
So there's our answer. It might need to be simplified. That's 30 over 8, which is 15 over 4. In other words, dividing top and bottom by 4. So this was actually a two-step problem by cross-multiplying. I could also have viewed it as, well, let's multiply both sides by 5 and then divide both sides by 2. You see how that works? In other words, if I multiply both sides by 5, I have 2x equals 60 over 8. Then I divide both sides by 2, and I have x equals 60 over 8 times 2 in the denominator. So I get my same 60 over 16, which is 15 over 4. So I get the same answer in the same number of steps. So, as I said, there's always multiple ways to do these things. And minus 8 equals 2 over x.
Okay. First, do you multiply
By?
x?
Yes. In other words, if I were to write out what are the 5 steps in solving an algebraic equation, the first one would probably be get rid of all denominators. Whatever you have to do to get rid of all denominators. Well, we have a denominator here, x. So I want to get rid of it. So let's multiply by x, means minus 8x equals 2. Now what?
No, divide.
By?
8. Negative 8.
Negative 8. So that becomes negative 2/8, which is equal to negative 1/4. Okay, I think I can do this one. let's see, we got y equals minus 4x plus 3, and we got y equals x minus 7. So I'm going to draw a little grid here. We don't have to be real exact. I'll grid it up a little bit. 1, 2, 3, 4, and 1, 2, 3, 4, 5. Let's make our grid look like that. Okay, how do we plot the first one? How do you plot a linear equation?
Wouldn't you do 0 at 3?
Uh-huh. In other words, what's
that
that called?
That's the constant 0.
Okay, if we're working off the form y equal mx plus b,
Yeah, it'd be b.
that's called slope,
Okay.
and that's called y-intercept.
Yeah.
And the y-intercept is where x is equal to 0. In other words, plus 3, which is right here. So we know that this line, and it's going to be a straight line, because it's linear, it's not x squared, it's just x. We know that that has to go through that point. What's the slope of that line?
Is that 3?
Remember, m is the slope. So what is the coefficient of the x term? What is the coefficient of the x term?
-4.
That's the slope. Whatever that thing is, that's the slope.
Yeah.
How do we make -4 slope on the thing?
Do we go down 4?
And over
3.
1. Down 4 over 1. Remember, slope is rise over run.
Okay.
So I want to go over 1 and up 4. And notice that it doesn't really, I'll go down 4. Okay, so I go down 4 to about right there. And which way do I want to go over 1? To the right or the left?
To...
In other words, we want a negative slope. I've got to go, no, if I go to the left, I'm going to end up with a line that's got that kind of orientation. That's a positive slope. Okay, a negative slope looks like this. Let's talk about that. Let's talk about the difference between slopes. What kind of slope is this? Positive or negative?
That's a positive.
Not only is it positive, it's a slope of 1. In other words, I got to go up 1 and over 1. Up 1 and over 1. The rise is the same as the run. Okay? What kind of slope is this? A bigger number or a smaller number?
Bigger.
Yes. Let's say this is maybe 2. What kind of slope is this? Bigger or smaller than 1?
Much smaller.
Slope is 1/2. In other words, flatter slopes have positive slopes. This is still positive. All three of these are positive. But the positive slope that is bigger than 1 is a steeper line. A slope that is between 0 and 1, like 1/2, is a flatter line. Okay? Those are all positive slopes. Now let's look at some negative slopes. What is that slope?
That would be at 1.
That's -1. Slope equals -1. which means in order to get a negative slope, I got to go up and into the left, or down and to the right. Either one. But that's the key thing, is if you have to graph a line that has a negative slope like we did with this first problem, we were looking for a -4 slope, we know it has to have this orientation of upper left going to lower right. So -4 slope would look something like that. Steeper, because the number is bigger. Actually, the number is smaller. -4 is a smaller number than -1, but the size of the number is bigger. 4 is bigger than 1, so it makes the slope bigger. But that's a negative slope, just like this one. This slope here is also negative, and that would be negative, let's say, 1/2.
Yeah.
So this is what negative slopes look like. So whenever you have to graph something, when you're done, it doesn't matter whether you go up and over, which way, just make sure you end up with a negative slope. In other words, if we go back to this problem,
Yeah.
and I started at 3, so I went down 4, I knew I had to go to the right one, not the left, because if I'd have gone to the left one, it would have put it there, and I would have ended up with a positive slope. So the one thing I knew is whichever way I had to go, I had to end up with a negative slope, so I knew I had to go to the right after going down 4 and then over 1. Go in the direction over that creates the proper orientation of the slope. Okay, so this is our line y equals -4x plus 3. Now let's graph the line y equal x minus 7. Where does that start?
Will that start as -7?
Yep, that's the y-intercept. Learn the words. Learn to call that the y-intercept. It'll make it easier for you.
Okay.
Okay? So that's right there, approximately.
Yeah.
So we know this line goes through that point. What's the slope on this line?
It's x. So it's unknown.
No, remember the slope is the coefficient of x. The slope is never x. It's y equal mx plus b, and m is the slope. So what's the coefficient of x here?
It doesn't give you the slope.
It's 1.
Oh.
In other words, when you don't see a coefficient in front of a variable, you always assume that it's 1. So we have a slope of 1. We know what slope of 1 looks like. Got to go up 1 to the right, or up 1 and over 1. That'll give us a positive slope. There's the intersection that they wanted. And that is the answer to these two equations. In other words, if you were given both of these equations and said solve these two equations simultaneously, the answer is where they intersect. In other words, at this point right here, both equations work. That point is on both equations. So whatever the x and y value is of that point, that's the answer to these two equations. Have you gotten yet to solving simultaneous equations? That seems a little advanced for you.
I don't think so.
Well, this is probably the introduction of it. In other words, if we did this on this graph paper here, we would be able to be a little more precise. I wouldn't have to approximate. And we'd be able to actually read the answer off of the graph. I don't know what that would come in at. Maybe it's 2 comma minus 2 or something like that. But whatever that point is on the graph is the solution to these two equations. That's
Okay.
what they're leading at here. Now, what was that? Was that 5, 6? No. What was that?
Yeah, sure.
Was it 5, 8? Must have been 5, 8. Yeah. Okay.
Yeah.
So we want to look at 5, 9. Why do these tiles fit this equation?
Because
Remember how you did it in reverse? Remember how you came up with the equation based on the tiles?
yeah,
Okay.
it's because figure 0 has 10 tiles in it, and it goes down 3 every single time.
So in other words, when x is 0, y equals 10. When x is 1, y equals 7. In other words, what this represents is that if we plug in for x this 0, 1, 2, or 3, we get the number of tiles that are going to be in this thing.
Yeah.
Notice if we plug in 3, there should be 1 tile. Minus 3 times 3 is minus 9 plus 10, that's 1. So these tiles represent this pattern. Is this new stuff for you, or this stuff that we're looking at right here, is this new or is this old?
We haven't even gotten to chapter 5 yet, but like
Okay.
I've done this stuff. Like I've done this stuff before.
That's good. It's not a problem getting you ahead anyway. It's actually good, because if we get you a little bit ahead when you go through it in class, you'll be more likely to understand it if we've talked about it before. All right. 2 ways to do this problem that are significantly different from one another.
Yeah.
What would you do?
Pretty sure I know one of them.
What's one of them?
I would find a common denominator first.
Okay. Let's do it that way, and then I'm going to show you afterwards an easier way.
Okay. Which is 2. That's one of the common denominators.
Actually, it's not. The common denominator is 6. Remember, the common denominator always has to be divisible into every number. Every number has to be divisible into the common denominator. If I said the common denominator was 2, well, that's divisible by 2, but 2 is not divisible by 6. It is divisible, but it doesn't produce a whole number. And that's what we mean, is we need the common denominator to be divisible by every number. So 6 is going to be my common denominator. What's my numerator over here? What is x over 2 in terms of sixths instead of halves?
Would it be 6x?
No. What we do here is we have to multiply this. You can only multiply. Remember, when you're dealing with fractions, it's not the same rule as dealing with equations. You can't do anything you want as long as you do it the top and bottom. That's not true. Equations, you can do anything you want to the left side as long as you do it to the right side. But when you have a fraction, the only thing you can do is multiply or divide it by the number 1. That's it. I cannot square top and bottom. I can't add 2 to the top and add 2 to the bottom. I can't do any of those things. What I can do is I can multiply it by the number 1 Well, my number 1 is 3 over 3.
Yeah.
Notice that gives me 6 in the denominator, and that's what I'm looking for.
Yeah.
So this would be 3x. In other words, x over 2 is the same as 3x over 6.
Okay.
And now I have a common denominator. So how do I add these?
Do you just add them across?
Well, you leave the denominator the same, because that was the whole point in finding a common denominator. And now you add the numerators. What's 3x plus x?
4x.
Uh-huh. What's the next step?
Do you multiply?
By?
6.
Okay. And the final step?
Divide by 4.
There's your answer. Now let's go back and let me show you maybe an easier way to do this. Instead of finding a common denominator, is there any number that I can multiply both sides of the equation by and get rid of all my denominators in one step? Now this is different than adding two fractions using a common denominator. This, I want to find a number that I can multiply the left side of the equation by and the right side of the equation by, and after I'm done I will not have any denominators left. Because denominators make equations hard to solve. You usually want to get rid of them the first thing. What if I multiply by 6? Both sides of the equation. Now distribute the 6 to inside here. What's this become?
6x over 2.
Which is 3x. What's this one become?
Also 2x.
Okay, when I multiply 6 times x over 6, what do I get? 6's cancel. 6 divides into 6 one time. So you're left with x.
Okay.
Okay? And then I have 42 on the other side. Now the problem's a whole lot easier to solve than it was before, right? We don't have any fractions. We got rid of all the fractions with one step of multiplying both sides by 6. And now we have 4x equals 42, x equals 21 halves. So I personally find this easier than trying to find a common denominator and add the two fractions. Now you'll notice that the number that I multiplied both sides of the equation by was the same as your common denominator. And that's usually going to be the case. Not always, but usually. So I prefer that step as a first step myself.
Okay.
I'm concerned about a couple of things here. Tell me what this is. Two-thirds times 3/4.
Wouldn't that be 6 over 12?
Yeah.
Which is 3 over 6.
Which is 1/2. In other words, multiplying fractions is a piece of cake. You multiply numerators, you multiply denominators. Okay? What is this?
So you multiply 6 by 3.
Right. In other words, there is a presumed 1 under that 6. So it's just like multiplying fractions. So it's 18 over 4. We don't have to write that 1. When you're multiplying a whole number by a fraction, you multiply the whole number by the numerator. Leave the bottom the same. Okay? So when I said 6x, I shouldn't even be using this x for multiplication there because we're doing algebra now, so x should be a variable. But when I said 6 times x over 6, do you see why the 6's cancel? In other words, if I multiply the numerators, I get 6x over 6. And then I can divide top and bottom by 6, and that becomes 1, and that becomes 1, and I just end up with x.
Yeah, because this one's a multiplication, and the one below it is a division.
Division is just as easy. Tell me what this is. How do we divide a fraction by a fraction?
Do you have to find the decimals first?
No. It's real easy. You turn it into a multiplication problem. The way we turn it into a multiplication problem is we flip the bottom and multiply it by the top. In other words, this is the same problem as dividing by 3/4. And we already know that multiplication's easy. So division is easy. Multiplication of fractions and division of fractions is the easiest thing in the world. What's hard is adding and subtracting. In other words, if I want to take 5/7 and subtract 1/5, that's hard to do. Now I have to find a common denominator. So always remember that multiplication and division of numbers, variables, fractions, always much, much easier than adding stuff or subtracting stuff. That's why in this problem here, instead of finding a common denominator, I just want to get rid of the denominators in one step, because denominators make solving equations harder. So if you can do anything to get rid of the denominators in one step, do it. In other words, if I had this problem,
Yeah.
this looks brutal, right? Winter?
Yeah.
If I had this problem, rather than finding common denominators, I'm going to multiply both sides of the equation by the number 12.
Why by 12?
Because that's the only number that will get rid of all 3 denominators in one step. This becomes 4x, this becomes 3x, and this becomes minus 2x. So I've taken a very complicated problem with 3 denominators and in one step changed it to a real easy problem. In one step. So think of that solution as your first solution instead of always finding a common denominator and adding each side. All right, Winter, I need to run. I got another appointment.
Okay.
Talk to you next Thursday.
All right, thank you.
You're welcome. Bye-bye.